Hey guys, so today we're going to be discussing a little bit about the properties of increasing and decreasing functions. So here we have a function that's given to us and it's continuous over an interval a to b and it's included because the brackets means it's included. And it's also differentiable on the domain a to b not included. So if we have f of x is continuous and differentiable over a certain domain, we have three rules. The first one being if f prime of x is greater than 0, f of x is increasing. Now f prime of x is the slope, and we're essentially saying if the slope is greater than 0, the overall graph is increasing. And we see that in a lot of our problems. We can see that, okay, if we have this line, y equals x, we see that the slope is positive, and it is increasing left to right. So that's one example. Another condition would be if f prime of x is less than 0, meaning that it's negative, the overall function f of x is decreasing. Once again, we can see that if we have another graph and it goes like this, somewhere like that. Oh, not like this, guys. If it goes like this, yeah. And we see that it is a negative slope since it's decreasing left to right. So then this overall function is decreasing. Now, our third rule is if f of x equals 0, then f of x is constant. It is constant. An example would be just a straight line, maybe like y equals 2. Because, this is f prime. If f prime of x is 0, then f of x is constant. Now that we know all these three rules and how they apply to graphs that you may have already seen, let's move on to some examples. Alright, so our first problem is y equals x plus 1 over x, and we're supposed to see at what domain this graph increases and decreases. And we know by just looking at this, we know x can never be equal to 0, so that is an important thing to keep in mind. And we have to first start off by finding this overall slope function of this function, f of x. And I have done that for you, so we know that y prime is equal to x plus 1, x minus 1 over x squared. And now we have to see at what values of x does y prime equal 0. So if we replace x equals negative 1 and x equals 1, we see that y prime is 0. And keep in mind, x cannot equal 0. So in order to find out which values of x this function increases and decreases, we have to make a variation table. And there are multiple ways you can solve this, but I feel like the most visual way is to make a variation table. So how do we make one? Well, we have three important components when making a variation table. We have the x value, we have the y prime value, which is the slope, and we have the y value, which is the original function. And now we're just going to make a table. Alright, now we have made a table. I may need more rows, but we'll worry about that later. More columns, my bad. So let's start off with the three numbers that are crucially important. Negative 1, 1, and 0. And let's put them in order. So this is going to be negative 1, 0, and 1. Oh, that's right. I need another column. And these boxes you're just going to fill with whatever number. So essentially, this is all the numbers less than negative 1. This is all the numbers in between negative 1 and 0. All numbers between 0 and 1, and all numbers greater than 1. Let's move on to y prime. We know that when x is negative 1 and 1, y prime is 0, so we can just substitute that. And we know that when x is equal to 0, well, that's not possible, right? So there's no y prime. We just put a kind of cross over there. And same thing with y. We're just going to put another cross since we obviously know it can't be equal to 0. What about these boxes? Well, let's take any number less than negative 1. Let's say negative 2, and replace it in this. We know that this is going to be negative 1, negative 3, and this is just going to be a positive number. So overall, this will be a positive number. So we're just going to write the sign. You don't actually have to calculate it, you just have to write the sign. And same thing here. Pick a number between negative 1 and 0, let's say negative 0.5. Let's put negative 0.5 here. We get positive, positive, negative, positive, which is just negative. Same thing over here. Let's put 0.5. This is going to be positive, negative, positive. This is negative. Let's put 2, since it's a number greater than 1. Here we get positive, positive, and positive. So we're just going to do that. Then for this one, we're going to show the direction. So since it's positive, it's going to be increasing, as we said over here. If it's negative, it's going to be decreasing. And we're just following that pattern. We're just going to fill that out. Now this is the easy part. Just plug in negative 1 in for x in the original equation, and you're going to get negative 2 and 2. So let's now see where it's increasing and decreasing. We know that this is increasing when, let's just write this, increasing. When is it increasing? It's increasing when x is less than negative 2, because you see it's going up. It's increasing when, oh, not negative 2, my bad. Negative 1, because we're talking about the x values. And we see that we are also increasing when x is greater than 1. When x is greater than equal to 1. Now, when are we decreasing? So, let's write decreasing here, decreasing. We are decreasing when in between negative 1 and 0, so negative 1 and 0. So there's no equal to and 0 because we know that's not possible. We see it's also decreasing between 0 and 1. Is 0 and 1. Once again, no equal to sign because, well, there's nothing over here, so no equal to sign on the 0. So this function f of x is increasing when x is less than equal to 1 or when x is greater than equal to 1. And it's decreasing between negative 1 and 0 and negative 1. So to get a visual representation of this, here is a graph to this way. And essentially you can see it's kind of a funky looking graph. It has asymptotes, more than one asymptote, but we're not going to get into that in this video. And you can compare when it's increasing and decreasing by looking at this graph. And that is it for this video. Just make sure to keep these rules in mind. And this question was a pretty difficult question. It wasn't like an easy low-level question. So if you guys solve this on your own, great job. And I will continue to make more of these videos if it continues to help you. And I'll see you guys next time. Bye!